चले, shall we? So we were discussing about hypermetropia. Very quickly we'll finish this off. Hypermetropia, a condition of number one, farsightedness. So we'll just write the points today. This is farsightedness. That is, person can see far, cannot see near. So we write cannot see near objects. And the reason for this is near point has shifted beyond 25 centimeters, which is the least distance of distinct vision. Right? And the problem that is happening is, from the eye perspective, we will say that the eye has less convergence, unable to converge the. That means the eye is having high focal length. Usually the reason for this is small eye. So your desired should be something like this, whereas the existing eye is like this, right? The desired is like this, the existing eye is in this way. Now, one of the reasons for this also may be that the person's ciliary muscles have become weak, and as a result the ciliary muscles are not able to move. So we will see what happens in this case. So from the perspective of physics, what do we say? We say that the near point has moved away. So let's first diagram that I'll draw, we'll see a hypermetropic eye. Hypermetropia. So let's see a hypermetropic eye. So what is happening in a hypermetropic eye is, so this is the eye lens, and let's say this is the eyeball, right? So this is the near point. So this is my normal near point, and if this is the near point, this distance should be 25 centimeters. I am unable to, the eye has less convergence power. As a result, the image is forming beyond the retina. So say the image is forming here, out here. This is the problem with the eye. Okay? The defect with the eye. This is the exact near point. Now, how is the eye then able to see this eye? This way, if you learn, you will understand better, right? So let's say, what is the time for the class, my dear? What is the time now? Okay. So what is the exact scenario? This person will be able to converge vision on retina when the near point has shifted away. So this is his new near point, n double dash. This is the problem. This is the problem with viewing near objects, and this shows you that near point has shifted. Near point has shifted, and shifted to where? That is greater than 25 centimeters. So it has shifted to n double dash. So this was the original near point. This was the original near point, which is n, and at original near point, convergence is happening beyond the retina. I hope now you are able to understand the case. This is the first diagram. This is how this is the problem of the person. A near object is the image is being formed beyond retina. Is he not able to see near objects? He is able to see near objects, but not at 25 centimeters. He is able to see them when they are at n dash or n dash. And n dash is how? N dash is greater than 25 centimeters. So if it is greater than 25 centimeters, the image is forming on the retina. And if it is at 25 centimeters, image is forming beyond retina. Now we will rub this, okay? So we'll discuss both the cases, how this is corrected. If this diagram is over, then Can I rub the left side then slowly? Okay. So let's understand the correction. Correction. So the correction would be, understand it chronologically, increase the convergence. Increase the convergence. How? By adding a convex lens. Convex lenses are converging lenses, so we will increase the convergence by adding a convex lens. Now this convex lens power has to be adjusted. Has to be adjusted. This is what the optometrist will do for you. So when he's adjusting the power, he is actually playing with the focal length. So you need a desired focal length. Are you able to understand, children? See, we're trying to do it in chronological manner. You have to increase the convergence. So in order to increase the convergence in front of your eye, I need to put what? A convex lens. So era gara convex lens डालने से तो नहीं होगा. Your convex lens, where is your specs? So looking at your eye, I can understand there is discomfort. So you need to put a convex lens. Now the convex, she is also hypermetric, I am also hypermetric, but our hypermetropia may be different. So the convex lens that I put for her may not work for me. So what we are trying to do? We are trying to find a convex lens of appropriate power. And power comes from where? Focal length. So we are trying to get a desired focal length. Now how do we get the desired focal length? ये सब लिख लिया तो सुनो. How do you get a desired focal length? Now, where is the man able to see? N dash. N dash को तो वो आराम से देखता है ना. So our idea will be, just listen this, then you will understand. Our idea will be, I'll draw a next diagram also. I will try to put a convex lens out here such that this convex, this he cannot see. But if this image can be formed here, he can see. Yeah. That is the same thing we did in myopia. Yeah. Far object we brought to the near point. Yeah. Here our job is, with this lens, actually there are two ways of understanding. One is we need to increase the convergence. To increase the convergence, we have added this lens. This lens will feed the rays which are more converged, and then ये बाकी का converge कर देगा, ठीक है ना? But the exact, if you want to know the exact reason, what it does, it actually produces, this is the object which I am unable to see, it will produce its image out here. Now once image is produced out here, yeah, I can see it, right? So our job will be what? So we'll draw that diagram. So add a desired focal length such that image of near point N is formed at N dash. N dash is what? The current near point of defective eye. This is for desi language लिख रहा हूं ताकि आपको समझ में आए. Image of the near point. This near point means the LDDV. The image of the near point is formed at N dash, which is the current near point of the defective eye. After that, person can see, no issues. Have you understood the funda? ये दिखाई नहीं देता है, ये हमें दिखाई नहीं देता है, ये दिखाई देता है. यहाँ का चीज को अगर यहाँ फोकस कर दे तब दिख देंगे. तो वही करेंगे अभी, ठीक है? So I'm just rubbing both the diagrams and let's try to see what is the magic that is now happening. Okay, so this thing you remember, increase the convergence. So if somebody tells you what is the role performed by the convex lens, the role performed by the convex lens was to increase the convergence straight away, and that we did by putting a convex lens of a desired power or an appropriate power. So power means we'll play with the focal length. So the focal length is adjusted such that the image of the LDDV, that is the least distance of distinct vision, is formed at the current near point, which is my defective near point, more than 25. And once it is formed more than 25, my eye can see it. तो आइए उस डायग्राम को पहले बनाने की कोशिश करते हैं. Suppose this is my eye lens. My eye lens in this case will be slender. My eye lens is supposed to get bulger, but it's not getting bulged, right? So then I add what? I am adding the convex lens additionally that I am putting, right? So if I put that convex lens, now let us make our eye. So this is my eye. So let's see what is happening. This is my exact near point. This is the exact near point. Exact means the LDDV. This is LDDV which is equal to 25 सेंटीमीटर्स. ठीक है ना. 25 सेंटीमीटर्स को हम देख नहीं पाते हैं, तो हम पहले क्या करेंगे, 25 सेंटीमीटर से रे ऐसे गया मान लो, सॉरी ज्यादा हो गया, राइट. इसका इमेज कहां पे फॉर्म होएगा, इसका इमेज फॉर्म होएगा द डिफेक्टिव नियर पॉइंट पे. दिस इज एन डैश, दिस इज द current near point, that is the disease wala. Now after this what happens, if the rays are coming from here, then the image is formed exactly out here. Yes, that is the case. Now we are able to see.
The rays are coming from the current near point where they see.
करंट नियर पॉइंट से अगर रेज आएंगे आंखों में ना, करंट नियर पॉइंट से आंखों में रेज आएंगे. सुनिए फिर से इसको कलर से बनाता हूं, सोचो. अभी जो बना रहा हूं वो करंट नियर पॉइंट से, करंट नियर पॉइंट से अगर रेज आ रहे हैं लेंस को ना ऐसे, तो वो रेज बाहर जाके मीट कर रहे हैं. ठीक है. ब्लैक इज व्हाट, black is actually showing the rays which are coming from the exact near point. This is the LDDV, means it is for you, me, defective person, everyone. They are first coming on the external lens. External lens is forming this image out here, and if the rays come from this particular point, that is yahan se agar rays aaye na converge hoke, then they will exactly form here. That is the idea. Have you understood? Diagrams आपको इतने आते नहीं, आपको पूछेगा defect of vision and what is the role? What is the role? ठीक है? Hypermetropia is clear. So hypermetropia generally when it is happening at your age, either your eye is small or there is a inborn problem with your ciliary muscles. ठीक है? For the reason which you are unable to see. After hypermetropia, so can I rub hypermetropia? I think we have discussed enough about this. So we now take up, say, a problem on hypermetropia, and we will see how to give the person a particular lens. ठीक है, एक प्रॉब्लम लेते हैं. जैसे मान लो ऐसा है कि this is a Lakshmi Singh problem. So our problem is something like this. See, they say that near point of a person means the person has the disease. What disease? Hypermetropia. This person has a disease which is hypermetropia. I'll just take the figures. Okay, now so the near point of this person, if this person did not have a disease, where should be the near point? 25 centimeters. Now since he has the disease, near point will get shifted away, so the near point has now become 1 meter. 1 meter बोले तो कितना बच्चा? 100 centimeters. The near point has gone 1 meter. But once again a small question. It is advisable that here we do the problem in meter. End of the day we have to give the power of the lens. फिर सेंटीमीटर मीटर होएगा तो रख लेते हैं इसको. ठीक है ना. So this is the case. They have asked us that they have asked the advisory of the correction lens, and that is what type of lens you will give and what is the power of the lens. ठीक है, समझ में आया. एक आदमी अभी 1 मीटर तक ही देख पाता है, 1 मीटर से सामने आ जाने से the person is no more able to see. ठीक है ना. Now we have to give the person a correction lens. Now you just listen to one English line and everything will become clear. End of the day we have to use this formula, 1 upon f is equal to 1 upon v minus 1 upon u. Our problem is to get what is what. Now you just think, look at me, where is the person able to see now? Here. The problem is this is right now 1 meter for the person. So I'll use a sentence, देखो इससे सब clear हो जाएगा. A person can see an object kept at 25 centimeter if its image is formed at 1 meter. I'm a defective person. Can I see a 25 centimeter object? No. But I can see a 25 meter object. Rather, I'm changing my language again. I can see an object placed at 25 centimeter. By now you're able to decode. I can see an object placed at 25 centimeter if the image is formed at 1 meter. So can I now say that my image distance should be equal to 1 meter, but I will take this as negative 1 because everything is this side, and my object distance is negative 25 centimeters. इतना ले लेने से हो जाएगा केस. Are we fine? Again सुनो, I can see an object placed at 25 centimeter if the image is formed at 1 meter. मायोपिया में जस्ट उल्टा था. I can see an object kept at infinity if the image is formed at 20 whatever is the new far point. ठीक है ना? तो आइए इस प्रॉब्लम को करते हैं. Right? So we'll make this stylish now. So how to minimize our calculation? 1 upon v. Okay. So 1 upon how much? 0.25. So just make it 25 and you can make this as 100. Did you understand? 1 by 0.25, because we have to make this in, I'm taking everything in meters now. Why did you take it in meters, sir? Oh, because I want ultimately in power. So 1 upon 0.25, if I multiply top by 100 and bottom by 100, what does it become? 100 by 25? Right? But this is minus, huh? This is minus. 100 by 25 is nothing but negative 4. ठीक है? Negative 4 minus 1 upon u, negative 1. So ये negative 1 को काट देने से it becomes plus 1.
Yeah.
Which one?
Like minus 1 plus 4.
Right. Look, wait. 1 upon negative 25 centimeter. V is negative. Oh, sorry. Ulta ले लिया ना. V is negative 1. Yeah, sorry. So 1 upon negative 1 means negative 1. चलो 1 upon negative 1 minus 1 upon negative 25. So if it's 25, this becomes 100. So if it's 125, ultimately it becomes negative 4. Correct? So 1 upon f is equal to negative 1 plus 4. ठीक है? Which is equal to 3. So 1 upon f is equal to 3. Therefore f should be equal to so 1 upon f से हमें problem है. So keep it at 1 upon f only. Or power is equal to 3 diopter. Positive. Calculation is correct. और 1 by f को क्यों change करने का? 1 by f हमें f थोड़ी चाहिए. They have asked us the power. हाँ, if they tell you find the length and thereby find power, then you should also find what is the value of f. But we can calculate this from here. Clear? Is hypermetropia clear? When they give you a myopic problem, they will tell you that the far point of a person has shifted to 400 meters. Far point of a person has shifted to 400 meters. So how should we say the problems? An object placed at infinity means object distance infinity can be seen if its image is formed at 400 meters. बस ये लाइन याद रखो. लिख लो ये लाइन चाहे तो. इस प्रॉब्लम में रेड कलर से लिख लो, आपको याद रहेगा. देन यू कैन डू एनी प्रॉब्लम. इस प्रॉब्लम के लिए रेड पेन से लिख लो या फिर डिस्टिंग्विश. अब द पर्सन can see an object placed at LDDV or 25 centimeter. The person can see an object placed at 25 centimeter or can see nahi, should be able to see. Then it's more better English. The person should be able to see the object placed at 25 centimeter if the image is formed at his current new point. Now you change that new point according to the problem that comes in the examination. His current new point. Here the current new point is 1 meter, so we took it as 1 meter. Clear? 1 year? समझ में आया? ये perfect. Sanvi, have you understood this problem? This language which I used at last. A person cannot see this, but he can be able to see this if the image is formed here. So the English we use is A person can be able to see an object placed at LDDV if the image is formed at his current near point. In this problem it was 1. If it is 2, we will use 2. And for a myopic eye, we should write a person can see an object placed at infinity, means object distance infinity, if the image can be formed at his new reduced far point. न्यू रिड्यूस फार पॉइंट, न्यू इंक्रीज नियर पॉइंट. ठीक है, बहुत हो गया. इसके बाद अगर नहीं आया तो समझ लेना तुमसे ये प्रॉब्लम नहीं बनेगा, छोड़ दो. ठीक है, अगला ये भी हो गया, ये भी हो गया. नाउ 2 मोर एंड वी नीड टू एंड. हाई बहुत दिन से बायो पढ़ रहे हैं बैठ बैठ के. नेक्स्ट इज प्रेसबायोपिया. Presbyopia. This is same as hypermetropia, but this is a symptom seen as one ages. Usually anytime greater than 37 years के आसपास से इसके symptoms दिखाई देने शुरू होंगे. So this will happen to all. It's same as hypermetropia. Happen to all. Reason is weak ciliary muscles, and they also become stiff. Weak होने के साथ साथ वो stiff बन चुके हैं. Less flexible. So if somebody asks you, let's do a quick group discussion, we'll understand. If I want to see something nearby, my eye should bulge. If my eye should bulge, my suspensory ligament should become loose and ciliary muscle should stretch, not contract, stretch. Ciliary muscle from top. See, I have to become like this. If I have to become like this, these become loose and the ciliary muscles they stretch. ये stretch करेगा इधर के side से, ये भी loose हो जाएगा और ये stretch करेगा इधर से. So the stretch is seen here and here. These become loose, but this is unable to stretch because this has become bad quality पनीर. Soft नहीं है अभी और ये रबर जैसा आ रहा है खाने में. नहीं तो बोलोगे सर हमेशा नॉन वेजिटेरियन एग्जाम्पल देते हैं. वेजिटेरियन एग्जाम्पल, ये स्टिफ पनीर हो गया. होता है ना रबर टाइप पनीर, फेंकू शादी में जाए खाने के लिए, तो ये वैसा पनीर हो गया. ये पनीर अभी और फ्लेक्सिबल नहीं है. दिस पनीर हैज बिकम वेरी टाइट. And this tight paneer will happen to all of us when we age, and the symptom will be same as hypermetropia. So what is the correction? Again, convex lens will be given to you, and at that stage these convex lenses are known as reading glasses. This is called as reading glasses, and person will need those. And a person who is suffering from myopia from childhood, he or she will be blessed with this also. So you have to go with double power. So you will have a myopic correction which is a concave, as well as a presbyopic correction which is convex. So you have to go for a bifocal lens. ठीक है, और presbyopia में कुछ नहीं है. Just remember one thing, hypermetropia is a disease which is seen at lower age also, which is uncommon. Presbyopia is a condition, ये होएगा ही, inevitable. ये एज बेस्ड है, ये होएगा ही होएगा आपको. ठीक है, understood. Presbyopia, nothing great as myopia, nothing different from hypermetropia. And the third one we know call as cataract. Okay, hypermetropic eye at your age as well as myopic eye at your age can be also corrected with contact lenses. So what does contact lenses do? तो आपके एज में आपको दो बीमारी नहीं हो सकता है. At your age you will have one disease only. Contact lens is something that you put over your eyelids, so it changes the entire curvature of your lens. Original eye lens, उसका curvature ही change कर देता है, बस that's it. So we'll discuss about cataract now. Cataract is further aging. Usually anytime from earlier they used to say 71, 72. Now I have seen people getting cataract surgery even at 55, 56. Okay, so anytime from 60 onwards. So what will happen? You will have clouding. Your lens is becoming old, as simple as that. Have you seen a brand new car's headlight? The glass is absolutely shining, and if you see an old Indica taxi now, you will see a yellowish type of a headlight. So the headlight has become, we say, clouding ho gaya hai. You can't see the maker's name and anything more on that. So there will be clouding, and due to clouding there will be what? There will be blurred vision. रेड मूवी देखा है? तो दादी को जो होता है ना, दादी जलेबी खाओ रामेश्वर का, रामेश्वर के दादी को यही है रेड, अजय देवगन से इनकम टैक्स रेड। सो रामेश्वर है ना, रामेश्वर के दादी, देयर इज वन दादी, शी ओनली गिव्स द क्लू ना, पता नहीं सीढ़ी क्यों बनाया, तो दैट दादी हैज दिस थिंग। Actually, see the some things you should also know. A person who starts suffering from, if you start getting diabetic, now a little bit more of biology. So what happens? The sugar in our body is absorbed by a hormone called insulin. Insulin is secreted in the pancreas. Now there are many interesting things. See, as soon as you go to an eye doctor, the eye doctor will first say nowadays, have you checked up with an endocrinologist? That is a person who checks for your diabetes and all. What will happen as you start getting 40 plus, धीरे धीरे, like my condition now, the insulin, the pancreas will become weaker and weaker. जितना इंसुलिन इसको सिक्रेट करना चाहिए, it will not secrete. ऐसा सिक्रेट नहीं करने से क्या होगा, ब्लड में ग्लूकोज का लेवल बढ़ जाएगा, and that thing is known as nothing but diabetic symptom, right? It starts from less, and we measure it in mg per dl, milligrams per deciliter. Mg per dl will be your glucose. And how do you monitor glucose? You all should know, because you all will have this disease coming to you at much more earlier age. You can actually say, sir is talking so bad, but sir is just talking like the movie Taken's dad. You will be taken. So this will happen to you, okay? Because of your food habit, so much of preservatives that you are eating. So आपको एक चीज क्या ख्याल रखना है, हमारे 3 टाइप के हम ब्लड चेक करते हैं। एक होता है फास्टिंग शुगर. फास्टिंग इज नील बाय माउथ, नथिंग यू हैव हैड एंड योर फास्टिंग शुगर. एट योर एज योर फास्टिंग शुगर शुड बी एनीवेयर बिलो 80 to 90, nothing more than that. How to check your fasting sugar? Just सुबह उठो, कुछ मत खाओ पियो, पंक्चर and check it on the meter. You should be between 80 to 90. In fact, अगर आप अभी से थोड़ा सा उपपटांग ज्यादा खाते हो, no matter how fit you are, you should check. Another comes is PP. PP is postprandial, मतलब खाने के बाद. Anytime 1.5 to 2 hours between after a good meal. Don't have a biased meal. आज मैं पॉपकॉर्न खा के टेस्ट करूंगा, नहीं, जो रोज खाते हो वही खाओ. There again you will test. You should test at that time anything from, at your age, not more than 120 to 130 should be. 120 is max, 120 to 130 mg per dl. And third is catch you anytime in puncture, that is called RBS, random blood sugar. Your random blood sugar should be, ऊपर देखो, your random blood sugar should be something around 9500 के आसपास आना चाहिए. So once the pancreas becomes weak, insulin will not be secreted, and insulin not secreted will straight away start impacting your eye also. That is called retinopathy. Diabetes आपका किडनी जैसी function, if your kidneys are not functioning properly, your eye will also start showing problem. Renal problem, eye will start showing problem. Just like people have heart attacks, you have the kidney starts flat, the kidney में भी वही होता है, वही अटरी जाता है. So retinopathy, so once you go, at my age, if I consult a doctor and I say something, he'll first ask me, when did you last check your eyes? Eyes kharab, diabetes automatic. So a diabetic person will have more chances of all these happening. ठीक है, तो ये ब्लड विजन हो गया, इसीलिए तो एज कम हो गया है ना. पहले ये सब 73 में होता था, अभी कम एज में होना शुरू हो गया. So it will be a blood vision, and there is a cloud which forms. It's, as I told you, a small, like something like, sometimes, have you peeled a boiled egg? When you peel a boiled egg, sometimes you get a membrane sort of a thing. Till that membrane does not get removed, the peeling will not be very, very comfortable. You find that, the eggshell is also coming out, the albumin portion, white portion is also coming out. So how to peel an egg properly? After you boil it, crack it and then just rub the egg this way. So that patla membrane jaisa aa jata hai. Now that is cured by surgery. We call it phacosurgery. So PHAECO. So that in surgery, they will just clean the cloud. Once they have cleaned the cloud, after that what they will do? They will implant an artificial lens nowadays. They'll put an artificial lens, and it all depends upon the cost of the lens. There are lenses right from 25,000 package to 1 lakh. If you are somebody who is still earning and you are a good architect or somebody and you don't want to compromise much, then you go for the higher lenses. Those lenses will be costly, and once those lenses are put, No matter whatever is your age, you can just kiss your specs goodbye and you should be able to see. Now what people do, people start compromising a bit, because again, very bad to say, the age at which you do that surgery, considering the amount of lifespan that you are left with, plus the cost that you are putting, plus what sort of job do you do. Now I'll tell you, like when my mother's eye changed, we went for not the high, not the medium, light upper, because what is her job? She should be able to see a person clearly, television clearly. If too much of stitching she does, which is also not advised, then put the specs on. पढ़ने के लिए reading glasses, because psychology becomes such that so many years that person has used the specs. Today, let's say our friend like these Zoes and the Aparnas, they're using specs from their childhood. Even if I say that the surgery is such now that you don't need specs, her psychology will say, no, 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 how can it be? So many years I've been wearing. So mild reading glasses are given. And that lens, contact lenses are taken out and replaced. This lens will be a part of you till your final day on this planet. ये और खुलेगा नहीं, ये लग गया एक बार के लिए. And these are known as IOL type lenses, intraocular foldable lenses, very very costly lenses. So they will come as package of 50,000, 45,000, 55,000, and insurance covers it. This is a good money making system for insurances. They are all daycare surgery. Morning you will go like a chicken, and not by evening, by 10 o'clock you will come back, and there will be people like line in front of you. They'll just take one, check, 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 go, and they'll put one green color on you. No bathing for 2-3 days, no water, no oil, no exposure to bright light, and then it becomes. So what is cataract? Cataract is a defect of vision which occurs due to aging, which occurs at aging, and the symptom of it is clouding of the eye lens arising due to blurred vision. How is it corrected? It is corrected by a cataract surgery, and after a cataract surgery, a permanent lens is put on your eye. Government also does these surgeries as camps, but government जो बैठाता है वो free में करते हैं लोगों का, and that is done with the cheaper quality lenses where specs will be needed. So if you want to be absolutely without specs, the more sugar you add to the porridge, it becomes more and more sweeter. जितने पैसे के लेंस लगाओगे उतना ही आपको विजन आएगा. But people compromise, saying that what is the job? Padna you can always use somewhere, but they will give you some small specs, because otherwise it's too much of stress on your eye. Okay? So now average everyone is with specs, and that too watching TV at night or something. Always try to read in proper light. In fact, that light is also less where you all are sitting. I need some break, I need to install some more tubes. So you should never read in subdued light. वो तो काम कभी मत करो. I used to do that a lot. I used to think that my eyes are very good. I used to read in subdued light. So that now you don't feel the change, but you will feel it once you're, like now if you ask me to read something, I'll first switch on my table lamp and then put it below like a microscope and then read it. Otherwise comfort doesn't come. Okay, so this concludes our topic of, so what is important here? The human eye, the parts, the iris, the rods and the cones, you should know about them. What is the retina's job? Aqueous humor, vitreous humor. What is the iris? What is the pupil? Why does symptoms like, why do you make your eyes small as soon as you get out of the cinema theater and you go outside? Why do you make your eyes big when you enter inside a cinema theater? What are the defects of vision? How are they created? And one common question, what is power of accommodation of an eye? What is power of accommodation? So in fact, if you ask me, what is the main reason of presbyopia? Presbyopia happens because of lack of power of accommodation, which I was earlier used to do that with my lens, that I am unable to do. When the power of accommodation of an eye ceases, and will it cease at your age? No. But sir, at my age also I have hypermetropia, that is birth defect. Birth से होके आया है आपको. At my age, the power of accommodation has reduced. I am no more able to accommodate objects near me. That is the condition of presbyopia. ठीक है? आइए. Now we go back again to core physics and we come to refraction, and we see refraction from a beautiful item which is known as a prism. As students of science, as I say, you should also have some things, articles. So prism is one article. Prism, you can, I hope every one of you have seen what a prism looks like. So the most common type of prism that we see are known as the equilateral prisms. So how to construct a prism? Very easy. In order to construct a prism, just make one equilateral triangle first. Easy है. ऐसे एक equilateral triangle बना लो. Right. And once you make an equilateral triangle, try to extend in this manner and make one more similar parallel equilateral triangle. मोटा मोटी. Then अब इधर को ज्वाइन कर दो. मेरा उतना एक्यूरेट नहीं बनेगा बिकॉज दिस इज अप्रोक्सीमेटेड. दिस इज लाइक अ प्रिज्म. This is a rectangular prism, okay? Base is a rectangle. Have you understood? The base is a rectangle, and from the four vertices, see how to make this prism? This, look at this table. Rectangular base, make a triangle here, make an equilateral triangle here, and join it. Right? What is the difference from a glass prism? In a glass prism, this face and this face are parallel to each other. Here they are like the roof of a house. European house. They are attached, but joint है ऐसे, and they are not at 90 degree. ये this angle is, this is a rectangular 60 degree. So we can have 60 60 60 prism, 60 30 90 prism, 45 45 90 prism. ये सब होते हैं. CBSE में इतना है नहीं, ये सब ICSE में प्रॉब्लम्स आते हैं. हमें सिर्फ थ्योरी पार्ट से समझना है. ठीक है, ये है प्रिज्म. सो वी व्हाट वी आर गोइंग टू स्टडी इज द रिफ्रैक्शन ऑफ light through a prism. So let's see the refraction of light through a prism. All of you have understood how a rectangular prism looks like. Just take your table, from your table make a triangle here, make a triangle here, and join the top. This is your table. This make a triangle. Okay. So what we are supposed to study is what happens in the case of refraction. So we have to know this ray diagram. ये हमारे लिए important है. आ जाओ इस ray diagram को बनाते हैं. Let's have a prism side as ABC. ठीक है बच्चा, इतना ओके? All of you? Okay. Once you have ABC, now we will make our first incident ray. And remember, we have the same concept. Outside right now we are where? We are at a medium which is air, and let's say this is medium 1, this is 2, this is glass, and again we have 3 which is air. But थोड़ा सा मजेदार चीजें होंगे यहाँ पे. So this is my incident ray. Look at my incident ray. This is the incident ray. My incident ray is AB. Is it clear? AB is my incident ray. So where is it incident from? Sir, it is incident from rarer to a denser medium, right? And B is the point of incidence. So I should first draw a normal at the point of incidence. So this is my normal at the point of incidence, which is N1 N1. N1 N1 is the normal at the point of incidence. समझ के करेंगे, सब समझ में आ जाएगा. ठीक है, अगला पॉइंट चलें. So what should happen? The ray should bend towards the normal. Yes or no? The ray should bend because we are going from rarer to denser. So the ray is bending towards the normal and hits the other side at C. So C is another point of incidence now. So few things that we should make out here is the angle between the normal and the incident ray. This is my first angle of incidence, which is known as I. Clear? Then this becomes my R1, my first angle of refraction. Are we fine? ठीक है. So AB will be known as my incident ray. Incident ray for medium 1 to medium 2. ठीक है, N1 is normal at B. I is equal to angle of incidence for AB side, right? R1 is equal to angle of refraction for AB side. BC is refracted ray for AB. ये AB सब लिख रहा हूं इसलिए ताकि आपको समझ में आए, ठीक है, इतना समझ में आ गया BC, ठीक है. So if you look at the interface AB, then light is traveling in what manner? Light is traveling from 1 to 2. Light is traveling from rarer to denser. That means it will always bend towards normal. BTN. BTM मतलब Benji turn mod, and BTN means bend towards normal. आधे को नहीं पता Benji turn mod क्या है, बताऊंगा. हाँ, कोलॉइड्स को पकड़ने के लिए वही चाहिए, Benji turn mod. BTM, BTN, MMBS, these are typical abbreviations in college days. MMBS is said to those girls, these are given by boys. MMBS means Man Man में Biswa Sundari. That girl thinks she is the most beautiful on earth. So it's not Vishwa, Biswa. MMBS. Man Man में Biswa Sundari. So that girl feels she is the most beautiful and everyone is eyeing her only. DCP, desperate for class participation. You have to ask some question in class, no matter how irrelevant it is, just to show that you study. ठीक है? So BTM इसके बाद ये समझ लेते हैं. Now we look for the side. Now we go for the side AC. So AC is such a side that you are going from 2 back to 3. So you are going from denser to rarer. So it will bend away from normal. Ban. BTN, ban. So bend away from normal. So first we should make the normal. So let's make the normal at this point. So this is my another normal. N2, N2. Okay? N2, N2. So now look here. This angle will be my I2. I2 is the new angle of incidence. Are you able to get it? So now for this part, BC becomes incident ray. And I'll teach you one more thing, though not in your syllabus. उसको पढ़ने से आप रेनबो अच्छा समझोगे, ठीक है? So विबग्योर ठीक है, अलग चीज. BC becomes your angle of, your incident ray. If BC becomes your incident ray, N2 is your again normal, and this is normal for what? The side AC. This is for the side AC, and I2 is my angle of incidence. This is again for the side AC. Now what is the scenario? Bend away from normal. So let us make it bend away from normal. So it should not bend towards the normal, it should bend away from the normal. अरे तुमको अभी इंक खत्म होना होता है. Please do the honors today by throwing this also. These are Sarthak's job. What you will not do? एक गुरु थोड़ा एक काम बोलता है वो भी नहीं करते हो, काम चोर, ठीक है? So this is the thing. Even this will go. Look at a chisel marker. So this is your, we call it as CD. So CD, what will we call CD as? Now there's a new word. CD we will finally call as emergent ray. Emergent ray, which is also the refracted ray. Refracted ray for side AB and emergent ray for the whole process. मतलब कैसे गया और कैसे बाहर आया. This is the incident ray, this is the emergent ray, and this one will be my R2. Okay, this is my R2. So R2 will be my angle of refraction, which is also known as for side AB. Now I can also call it as angle of emergence. प्रकट होने का एंगल कितना है, दिस इज ऑल्सो द एंगल ऑफ इमर्जेंस. ठीक है, Panda is clear now? Yes. Now one thing different, if you see when we started to do this diagram for a rectangular slab, imagine your rectangular slab, we used to find that the final emergent ray used to be parallel to the incident ray, and what we calculated used to be a lateral shift. You had a lateral shift. Here it will not be parallel. The reason is, though it is 1 to 1 air glass air, these two sides are at an angle and are not parallel. In that case, these two sides, the two refracting surfaces were parallel. Now the two refracting surfaces are not parallel, they are at an angle to each other. As such, you will not get a case when this ray is coming out parallel to same. So it will come obliquely bent. ठीक है, अब एक चीज हम यहां पे बनाएंगे. So we want to see, जाना कहां चाहते थे तुम? सर मैं जाना चाहता था इस रास्ते में, ये है हमारा जाने का रास्ता, पर गए कहां? सर मैं यहां चला गया. आए थे राम भजन को, ओटन लगे कपास. दिस एंगल इज नोन एज डी, angle of deviation. And ICC and all have lot of calculation. You will have same calculations in grade 12. This is known as angle of deviation. आपको कोई न्यूमेरिकल नहीं है इसका. क्या हो गया, इतना हंसी आ रहा है? अरे, so angle of deviation is the angle made by the emergent ray with the initial incident ray. Did you understand? The initial incident ray had to go this way, and the initial incident ray got deviated from its path. So the angle made by the initial incident ray and the angle of emergence is known as the angle of deviation. This diagram they may ask you to sometimes draw a neat level diagram of a prism showing the refraction. So if this question comes, it's full 5 marks. There's nothing wrong. As long as you understand, then you need not memorize it. What happens? There's a first refracting surface, there's a second refracting surface. Try to obey the rules. Rarer to denser, bend towards the normal. Denser to rarer, bends away from the normal. Bring your light in this way. Do you understand? Now see, now one lovely thing will come up. Once you're done with this, let me know. Now all the convex lenses that you studied, convex lenses are what lenses? Converging lenses. A convex lens is nothing but actually combination of prisms in reverse order. नीचे ऐसा प्रिज्म है, ऊपर ऐसा प्रिज्म है, इसीलिए कॉन्वेक्स में ऐसे ऐसे रे आता है. नीचे वाला रे इस साइड जाएगा, ये वाला रे इस साइड जाएगा. दिस इज द फंडामेंटल ऑफ अ कॉन्वेक्स लेंस. अ कॉन्वेक्स लेंस इज अ कॉम्बिनेशन ऑफ प्रिज्म्स व्हिच आर इन ऑपोजिट ऑर्डर. प्रिज्म क्या करता है? रे को नीचे की तरफ बेंड करता है. नाउ डजंट दिस लुक लाइक ए कॉन्वेक्स लेंस? सो ये क्या हो गया? ये अपसाइड डाउन प्रिज्म है, ये ऊपर की तरफ छोड़ेगा. दिस इज ट्रेपेजियम ऊपर, ये नीचे. सो दैट्स द प्रिंसिपल ऑफ इट. एंड इफ यू सी अ कॉनकेव लेंस, देन इट इज प्रिज्म्स इन कॉनकेव. देखो कैसा है, कॉनकेव इज लाइक दिस. इट्स अ प्रिज्म दिस वे, सो इट विल बेंड टुवर्ड्स दिस साइड. ठीक है, डन. Our next topic is dispersion of light. Before going to dispersion of light, one interesting thing I just want to share with you, because if you understand that, नहीं तो कोई बच्चा कभी कभी एग्जाम लेके आता है, एलन वेलन का, बोलता है सर ये हमने नहीं पढ़ा था. जान लो, जानने में क्या जाता है. ओके, नाउ सी वन phenomenon. Let's say this is an interface where this inner side is a denser medium, right, and this is rarer. Try to understand. You are inside a glass. You are inside a glass. आप denser में हो, बाहर वाला side rarer है. Let's make some incident angle ray. Suppose this is an incident ray. This is an incident ray. I should be able to make a normal here. This is the normal. Now, how are you going? Your motion is like this. You're going from denser to rarer. So it should be bend. Bends away from normal. So how you should bend? You should bend somewhat like this. What is this called? This is called my incident angle. This is my angle of refraction. Right? Now try to see. Now let's take another angle of incidence, another point of incidence. This. Increase the angle of incidence. We have increased the angle of incidence. Let's say this is I2, this is I1. What will happen to the angle of refraction? What it is? वो भी बढ़ेगा. Okay, this is not the angle of refraction. This is the angle of refraction. So the angle of refraction also increases now. Right? Have you understood? Don't you think that there will be a particular value of angle of incidence? There will be a particular value of angle of incidence at which you won't find any refracted ray, and the refracted ray will become just along with the path. Right? So understand. You studied the first topic as reflection. Sir, reflection is not happening. Yeah, reflection does happen. Reflection को तो आप मार नहीं सकते हो. Whenever light falls on any interface, some reflection will happen and refraction will also happen. We are concentrating on refraction. This thing is happening. So what are we concentrating? At a particular angle of incidence, you have a particular angle of refraction. Now, if you increase your angle of incidence, the angle of refraction also increases. Basically, what is happening? The refracted ray, rather than being here, is slowly now getting aligned. And don't you think at some angle of incidence, the refracted angle will be how much? 90 degree. 90 degree हो जाएगा? Will you be able to see the refracted ray? No. The refracted ray, no. This particular angle of incidence is known as critical angle. Critical angle. Why critical angle? Now the story is after this. So I call this angle as my critical angle. This is not there in CBSE, yeah? But you should know. पूछता है आपको कोई भी competitive exam दोगे. At critical angle, the refracted ray is lost because the angle of refraction has become 90 degree. Now what if you try to increase from the critical angle? Now let's say we take an angle called I, and I is greater than IC. I have gone beyond the critical angle. Right? I have gone beyond critical angle. At that time, the refracted ray will come this side. There will be no more refraction. The ray will come back to the same side. Such a scenario is known as total internal reflection. This is known as total internal reflection. I don't know why CBSE took it out. In our times, it was there. So what is total internal reflection? Total internal reflection is a phenomenon when the incident ray makes an angle greater than the critical angle. So what happens? Refraction as a phenomenon is lost. There is no more refraction. Ray at critical angle, ray was along the interface. Now ray has come on the same side. So what is happening? We were inside the glass. We are all inside the glass. This is what happens in diamond. Diamond जो glitter करता है ना, and for diamond, the critical angle is as low as 24 degree. 24 degree is very less. Means any ray which enters diamond के अंदर से, please understand, we are inside diamond. You are inside the diamond now. Any ray inside the 24 degree is very less. Any ray which is more than 24 cannot escape the diamond. It remains within the diamond. And so diamond follows total internal reflection. इसलिए उसका glitter बहुत ज़्यादा है. और एक जगह कहाँ ये use करते हैं? All you guys are using internet at home. Do you know the wire that is coming with internet at your home is not a conductor wire. It's called an optic fiber. Conducting wire में होने से क्या होगा? ये आप पढ़ोगे. If you take a wire from my house to your house, slowly the signal strength will fall down. The wires, when the Jio or the Airtel guy comes with your house, you will see he is carrying something which will preserve like anything. He has a pair of scissors जो वो कहीं भी नहीं छोड़ेगा. That is like the most precious instrument he has, absolutely sharp. and those optical fibers are very, very thin. They're just like the strand of one that sofa wire, and he'll just in one stroke cut it. Inside that there is a LED which glows, and the rays suffer total internal reflection. No amplifier is needed. It can travel, and all the undersea cables which are there from continents to continents, all these are coming due to this. Otherwise, how are you able to see the match on Hotstar? 2.6 crore people watching a match. Can you imagine how much of bandwidth is consumed? Wire se wo aayega hi nahi. This is optic fiber. Sometimes we have a cable cut. Are you aware? Across continents there are cables laid between Europe, North America, Asia, and all. So there is a huge. What are the type of communications we have? We have optical fiber cables. We have satellite communication. And if everything breaks, then what do you use? Radio. Like what they do to Russia, jam everything, but you cannot block radio. Radio can work. So this is optical fiber. This you'll learn in grade 12. Optical fiber also works on the principle of total internal reflection. So whatever rays are there, they're getting on reflected inside, and they keep on traveling. There is no wire inside what the cable that comes to your house. When you say I have got geo fiber, that's all optic fiber. A ray of light is coming to your home. That's all. And that ray they must have projected from some place, it is traveling till your house, क्योंकि उसको कोई obstruction ही नहीं है. समझ आया? What is total internal reflection? Total internal reflection जाने से पहले आपको critical angle जानना चाहिए. Critical angle is the angle at which refracted ray is lost. That means angle of refraction becomes 90. So you don't see the ray anymore. And if you go beyond the critical angle, then there is no refraction at all. Everything is reflection. रे उसी साइड वापस आ गया. ऐसे सिनारियो को हम कहते हैं टोटल इंटरनल रिफ्लेक्शन. हाँ, लॉ इज अ लॉ. विल इट फॉलो लॉ कभी मत पूछना, रॉन्ग क्वेश्चन. लॉ इज अ लॉ. लॉ विल ऑलवेज बी फॉलोड. ठीक है. सो आवर नेक्स्ट टॉपिक इज डिस्पर्शन ऑफ लाइट. आ जाओ. So in prism part, what all do we study? First we study what is a prism, then we see what is the ray diagram of refraction through a prism. Once you have seen the ray diagram through prism, additional one thing I taught you which is not there in your course is what is critical angle and what is total internal reflection, because as students of science you should know how communication is coming to your house. Now what we study is known as dispersion of light. ये 8 में भी तो पढ़ा था. बिल्कुल पढ़ा था. Dispersion of light. So the white light that you see, white light is actually composed of 7 fragments, right? The second fragments written from bottom are Vibgyor. Okay, na? And if you see it from ultraviolet to this side, then it is Vibgyor like this. This is what you see as light. This is light, and on this side we will have gamma rays, and on this side you will have radio waves. Okay. So what Newton did, Newton was the first person who actually said about dispersion of light. What is dispersion of light? Breaking of light, white light, into its 7 fragments when it is allowed to pass through a medium like a prism is called dispersion. Dispersion is the breaking of light into its 7 fragments. So dispersion में होता क्या है? So we will have a prism like this. Okay. So must be many a times when you wear watches to school, and after the lunch break, when the sun actually changes its position from this side to the other side of the window, and if you are that lucky, आपका घड़ी या कोई चीज रहने से you see that everything and you start playing that game. So dispersion कैसा रहता है? White light will be coming here. Okay, this is white light. Sir, does this light always needs to be from the sunlight? No, it can be from a electric lamp also. So you can have white light, and prism will split the white light into all its components. ऐसे करके. So you will be getting 7 different segments. Like this. And here the order is VIBGYOR, नीचे से विब्योर लिखना है, ठीक है। हाँ, ऐसा क्यों अभी सीखेंगे। अगर हम यहां पे देखें रिफ्रैक्शन, मैक्सिमम रिफ्रैक्शन इज व्हाट, बेंडिंग ऑफ लाइट। कौन ज्यादा बेंड हुआ, वायलेट ज्यादा बेंड हुआ, रेड उतना बेंड नहीं हुआ। तो सबसे पहले बात पूछते हैं, व्हाई डज दिस डिस्पर्शन हैपन। दिस डिस्पर्शन हैपेंस बिकॉज द कंपोनेंट्स ऑफ व्हाइट लाइट मूव विद द सेम स्पीड एज लॉन्ग एज दे आर इन द एयर। जब ग्लास में घुस जाते हैं ना, ये तो ग्लास है हमारा, दिस इज ग्लास, हियर द fragments which is the 7 fragments have different speeds, now if you ask from basic what is speed, c is equal to lambda into f, frequency into wavelength. Color is a function, the color of a light that you see, color is a function of wavelength. A particular wavelength will emit a particular color only. तो wavelength तो सबका अलग अलग पहले से रहता था, ठीक है, लेकिन सबका फ्रीक्वेंसी चेंज हो गया जाता है, ठीक है। देयर इज अ चेंज इन फ्रीक्वेंसी इनसाइड ग्लास। फ्रीक्वेंसी एक्चुअली डिपेंड्स ऑन सोर्स, बट ग्लास के अंदर देयर इज अ चेंज, सो एवरी 7 fragments now will have different speed. Now if you watch the diagram, then you see violet suffers maximum डेविएशन, है कि नहीं, एंड रेड सफर्स minimum deviation. Now you try to put your own thought process. Why does refraction happen? Refraction happens due to the difference in the speed of light. अगर आपका स्पीड कम है तो आप, स्पीड कम मतलब एनर्जी कम, you need shoulder to lean on, so you will bend more. So किसका स्पीड कम रहता है, वायलेट का स्पीड कम है। Inside glass, if anybody asks you whose speed is less, violet speed is less. स्पीड कम मतलब एनर्जी कम, बोला था ना आपको फर्स्ट क्लास में। अगर एनर्जी कम तो क्या हो जाता है, आपको सपोर्ट चाहिए, सो यू विल बेंड मोर। सो हु इज बेंडिंग मोर, वायलेट इज बेंडिंग मोर, रेड बेंड नहीं करता है। दैट्स द रीजन रेड इज ऑलवेज यूज्ड फॉर ऑल डेंजर एंड एवरीथिंग। ब्रेक लैंप्स में रेड क्यों डालते हैं, क्योंकि फास्ट का चीज नहीं, डेविएशन नहीं है। रेड विल ऑलवेज, इफ यू सी द बैकलाइट ऑफ अ कार एज रेड, no matter how foggy the night may be, you won't see the light getting scattered. आप उसको red में scattering नहीं है, आप उसको dot वैसे ही देखोगे। That's why in railway, what you call signaling and all, trains go at such fast rate, the driver has to see that signal. So अगर उसको red है, red ही दिखेगा आपको। red में किसी तरह का deviation नहीं होता है, because red speed is very high, ठीक है। So the 7 fragments. So what is dispersion of light? Dispersion of light is the phenomenon due to which white light, dispersion means white light splits into 7 fragments, and when it is passed through a prism, and why it is splitting into 7 different fragments? Because the 7 fragments have different speed inside glass. ग्लास के अंदर इनके स्पीड अलग होते हैं, और इनके स्पीड में रेड का स्पीड सबसे हाई होता है, वायलेट का स्पीड सबसे लो। देयरफॉर रेड सफर्स मिनिमम एंड वायलेट सफर्स मैक्सिमम डेविएशन। हैव यू अंडरस्टूड? बट द ब्यूटी, नेक्स्ट ब्यूटी इज, इफ यू हैव एन आइडेंटिकल प्रिज्म लाइक दिस, और इसको अगर आप इन्वर्ट करके यहां रख दो ना, then everything will again combine back to white light. This also Newton proved. This is called recombination of 7 segments into white light. Make sure these 2 prisms should be exactly identical in their refractive index, geometry, orientation. So if you keep 2 prisms neck to neck, if you separate them, you'll see, ये सब आप घर में भी कर सकते हो। अगर आप separate करोगे, you'll see this known as the Indradhanush, the Vibgyor. And again, if you join it back, then you can see white light. This is called recombination. And this you can also do with Newton's colored wheel. You know what is Newton's colored wheel? So if you color the wheels of a circle, concentric circle, and then move it at a speed, after some time everything will be appearing white. In fact, this t-shirt printing, cup printing, if you are trying to give your own what you call image to that designer or the printer, the printers have their printers set, the printing office will have their printers set to 2 different models. One is called the RGB model. RGB is the red, green, blue. So either you are drawing the way you are saving your JPG, that should be in red, green, blue format or CMY, cyan, magenta, yellow. So they'll ask you CMY format. If it is not confirming, then they'll tell you, "साहब print exact नहीं आएगा आपका." So that's called CMY or RGB. Yeah.
ये वाले डायग्राम में कुछ रेट टुगेदर यू सी लाइक तो फर्स्ट कौन सी
हाँ, प्रिज्म में डिस्पर्शन होगा, पर अगर आप व्हाइट लाइट मींस व्हाइट आ जाएगा इसके बाद और आपको दिखाई नहीं देगा। प्रिज्म में कुछ नहीं दिखाई देता है, प्रिज्म के बाहर दिखाई देता है। जैसे आप घड़ी वड़ी लेके एक्वेरियम, एनीबडी हु हैज एक्वेरियम इन हाउस, द एक्वेरियम हैज अ कर्व्ड कॉर्नर, सो द कॉर्नर बिहेव्स लाइक अ प्रिज्म. This corner of the aquarium will behave like a prism. Like we used to have any glass tank which you have, and when the sun comes in the western side in the afternoon hours, we used to see that vibrio right on the floor. ठीक है? इस डिस्पर्शन का एक रहता है एप्लीकेशन, रेनबो। पढ़ लें क्या अगले क्लास? Next class? Okay, next class. So next class you have to do rainbow, then why is the sky blue, early sunrise. Okay, but it's better to do next class, then we'll be able to finish the chapter.